First, I'm going to give you a brief background about our program, Animated Tracer. It takes a C# source file as input and produces corresponding WPF animations that represent basic programming language constructs. For example, statements, loops, and arithmetic expressions. These animations are designed to help novice programmers to better understand modern programming languages. As you can see, here's the graphical user interface of our program. We have adopted the open source IDE, ZAC IDE, as the base of extension, which looks and consists of several features similar to Visual Studio 2005. To save us some time, I prepared a sample source file to demonstrate some key features of Animated Tracer and the output animations. Here, we are going to take a closer look at the demo source code. The first few lines will show you variable declaration and initialization. Next is if statement, assignment, and expression evaluation. User-defined object creation, array initialization, and the last line, method call, parameter passing, returning, and for loop. To begin playing the animation, we have to first compile the source file to make sure it is error-free. The error messages are then shown in the results panel at the bottom. Before actually running the animations, I'll show you the outline view and abstract syntax view or AST view panels. The outline view shows the classes and their members in a namespace, and when you click them, it will highlight the corresponding fields and methods. For the AST view, it shows the generated abstract syntax tree from the source file, which may be helpful for some experienced programmers. And when you click on these tokens, it will also highlight its location in the source code. Like if you click on 5, it will go to the source line where it locates. Same goes with X and B. Alright, we can now start playing the animation by going to the menu, Animated Tracer, and click Start. And the animations will be played in the Animated Tracer panel. Here is the control bar with the Adobe skin from Windows Media Player. On the left, we have the play and pause button, stop button, decrease speed and increase speed button, with the adjustable speed levels from 1 to 20 times. The next button is the zoom button, with magnifying levels from 1 to 5 times. And the last button on the far right is the show or hide button, which is clicked to make the control bar auto hide or make it always shown. Alright, now let's continue with the animation. Just above the control bar is where the using statements items are normally located. In this source file, we have using system.collections.generic, and using system.text. For any code, the program will begin by showing the namespace, in this case console application 1, and the class inside that namespace, which contains the main method, in this case the demo class. We can move the mouse over most of the items on screen and it will expand, showing us more details related to that item, like what you've seen with the namespace and class just now. The class box displays the class members with information such as access modifiers, return type, and parameter types. If you take a look at the code, you notice that as the animation is playing, the corresponding code is also highlighted. This item fading in represents the main method, The header part shows method information, while the body part is where most of the actions take place. All method items will look like the main method. Now the program begins animating the variable declaration. The value 10 moves in from the right side of the method's body, and the variable b moves up from the bottom. An arrow then links the value item to the variable to represent the assignment. We can also click on the variable item to make it stay expanded, and if we click it again, it will go back to the normal state. For this simple arithmetic expression, we will show you how the program animates multiple calculations. It will first evaluate 4 minus 8 before getting the result -4. When it is about to evaluate the division, it sees that the next expression is parenthesized, so it calculates 3 minus -1 first. Next, the negative sign is given the value 1 due to the operator's precedence. After calculating 3 minus -1, the result is sent back to the division calculation to get the final result. Then, the final result -1 is assigned to the variable m. Here, we initialize some more variables, int x and y, for the next calculation inside the if statement. The if statement begins by checking if x with the value 5 is less than or equal to 3. The result is false. So it will go to the next condition. X